আজকে ডিসকাস করব রিয়াল কোয়াড্রেটিক ফর্ম। ওকে, সো ফার্স্ট সি দ্য ডেফিনেশন অফ রিয়াল কোয়াড্রেটিক ফর্ম। What is real quadratic form? An expression is of the form, that is this form, summation I is equal to 1 to n, summation j is equal to 1 to n, aij xi xj, right? Summation I is equal to 1 to n, summation j is equal to 1 to n, aij xi xj. Okay, this is said to be, this form, that is this expression is said to be a real quadratic form where aij, so this is symmetric, that is aij, so this equal to agi. Getting my point? Aij is equal to agi. Okay, and aij, so these are real, and this form is known as real quadratic form. Okay, that means a real quadratic form, that is a homogeneous equation. For example, if we consider this equation, suppose 3x1 square, right, minus 2x1 x2, right, plus suppose plus 4x2 square. See this expression, this is a real quadratic form. Here we consider two variables, that is x1 and x2, so that is summation. If we compare this, summation I is equal to 1 to 2, summation j is equal to 1 to 2, right, aij xi, that is here aij x1 x2, getting my দুটো ভ্যারিয়েবল আছে, ঠিক? So aij xi xj, I varies from 1 to 2 and j varies from 1 to 2. So that means quadratic form must be homogeneous equation. That is very important. That is a quadratic form must be a homogeneous equation. Getting my point? So a real quadratic form must be a homogeneous means the degree গুলো কি হবে? Same. See this, degree is 2, here degree is 2, here degree is 2, right? Okay, clear? So what we learned, that is a real quadratic form that must be a homogeneous equation in any number of variables. So this an expression is of the form this, where aij are real and aij is equal to aji. So this is said to be a real quadratic form in n variables x1 x2 up to xn. This is quadratic form in two variables x1 and x2. Okay, right? And every quadratic form can be represented in matrix form. Every quadratic form can be represented in matrix form. Suppose if we consider this quadratic form is basically represented by q, or we can also write this form x1. Suppose the quadratic form is denoted by this symbol, okay, q x1 x2 up to xn, or simply q. Okay, if we consider two variables, then q is a function of x1 and x2. If we consider n variables, then q is a function of x1 x2 up to xn, and this can be a real quadratic form, can be expressed in matrix form also. Suppose q is equal to summation I is equal to 1 to n, j is equal to 1 to n, aij xi xj, where aij is symmetric, right? It should be noted that this is symmetric, real symmetric. aij is equal to aji, and this so what is the associated matrix? The associated matrix will be a11 a22 dot ann, right? ann, a21 dot a2n, a2, this is a12, a11 a12 dot a1n, a21 a22 dot a2n, dot an1 an2 dot an. This matrix must be symmetric. this matrix must be symmetric, and x is equal to, if we consider n variables, then x will be x1, x2 up to xn. That means q, this expression can be written in the form q is equal to x transpose ax, x transpose ax. Okay, q can be expressed in matrix form, that is x transpose ax. If we consider this example, suppose we consider an example, this matrix A must be a real symmetric matrix. This is real symmetric, this is real symmetric matrix, and this matrix is called the associated matrix. Okay, okay, so suppose if we consider a quadratic form, so আমরা কোয়াড্রেটিক ফর্মকে কি করতে পারি, ম্যাট্রিক্স ফর্মে রিপ্রেজেন্ট করতে পারি। উই ক্যান এক্সপ্রেস the quadratic form in matrix form, right? That is, q can be expressed in the form x transpose ax. Okay, so let us consider an example. Suppose if we consider the quadratic form, suppose ax square, see this, ax square plus by square plus 2hxy plus 2gxz plus 2fyz plus cz square. Suppose we consider this quadratic form, ax square plus by square plus 2hxy plus 2gxz plus 2fyz plus cz square. So if we want to express in matrix form, that is q is x transpose ax, right? So here what is x? Here the variables are, that is x, y and z. So x transpose, so column will be row x, y, z, and a is the associated matrix. What is a? Just see, diagonal গুলো কি হবে, coefficient of x square, coefficient of y square, coefficient of z square, that is a, b, c. The diagonal elements are the coefficient of x square, coefficient of y square, and coefficient of z square, and the non-diagonal elements just 2 they divide. Okay, here the coefficient 1/2 coefficient of xy, so xy coefficient 2h, that means simply h, 2 they divide, right? xy xz coefficient ki 2g, so that means 2 they divide korbe, so that is g. Coefficient of yz, that is 2f, so 2 they divide, so that means f, right? So this is h, this is g, and this is f. Okay, so this is a, and this matrix, this is called associated matrix. Okay, so x transpose ax, what is x? X will be x, y, and this matrix is the symmetric matrix. Okay, so how to find associated matrix? What is the technique? Note this, that is, associated matrix is obtained by, note this, associated matrix can be obtained by coefficient of x square, coefficient of y square, coefficient of, suppose 3 cross 3, suppose we have 3 variables, coefficient of z square, right? Principal diagonal element, that is coefficient of x square, coefficient of y square, coefficient of z square, and non-diagonal elements, so 1/2 coefficient of xy, 1/2 coefficient of xz, 1/2 coefficient of yz. Okay, clear, right? So this is symmetric, so 1/2 coefficient of xy, so this will be 1/2 coefficient of xy. This is symmetric, 1/2 coefficient of xz. This is 1/2 coefficient of yz. Clear? Okay. Suppose if we consider a 2 cross 2 matrix, suppose if we consider a 2 cross 2 matrix, suppose if we consider a 2 cross 2 matrix, that means suppose if we consider this quadratic form, ax square plus 2hxy plus by square. ঠিক আছে, দেখো এখানে here the variables is 2, so we get a 2 cross 2 matrix. If there are 3 variables, we get 3 cross 3 matrix, 3 cross 3 symmetric matrix. Okay, if we consider n variables, so we get a symmetric matrix of order n. So the order of the matrix, that depends on the number of variables. ঠিক আছে, আমি কি বলছি, যতগুলো আননোন থাকবে, যদি এখানে দেখো x y z তিনটে আননোন আছে, so we get a 3 cross 3 real symmetric matrix. If we have 2 variables for this, suppose we have 2 variables x and y, so we get a 2 cross 2 real symmetric matrix. ঠিক আছে, so if we express this in a quadratic form, in matrix form, so what is the quadratic form? What is that? Is q matrix form, that is q. This expression can be written in the form x transpose x, right? So what is x here? What is x? xy. ঠিক, so x transpose, that means xy. Okay, what is the associated matrix? Coefficient of x square, that is a, coefficient of y square, that is b, 1/2 coefficient of xy. Coefficient of xy is 2h, 2 they divide, that means simply h. ঠিক, and what is x? X is xy. If we multiply this, you get this. যদি তুমি multiply করো, you get this form. Okay, if you multiply this, you get this. So an expression that is a real quadratic form can be represented in matrix form. Clear? So for a 2 cross 2 matrix, here the number of variables 2, so the associated matrix, how to find? This is the rule: coefficient of x square, coefficient of y square, and this will be 1/2 coefficient of xy, and this will be 1/2 coefficient of xy. So this is the associated matrix for this quadratic form, and this is the this is the associated matrix for 2 cross for 2 variables. Okay, here x and y. So if we have 3 variables x, y, z, then the associated matrix is this. Okay, ঠিক আছে, so let us consider an example. Suppose, I think up to this clear, right? So let us consider an example. Suppose we have this form. Suppose we have a real quadratic form. Suppose we have a real quadratic form. Suppose we have a real quadratic form, 5x1 square, right? 5x1 square, right? Plus 2x1 x2 minus x2 square. See this: 5x1 square plus 2x1 x2 minus x2 square. So this is a quadratic form in 2 variables, x1 and x2. So we have 2 variables, so we get a 2 cross 2 real symmetric matrix. Okay, right? So just you consider x1 is x, right? x2 is y, right? So what is the associated matrix? What is the rule? Coefficient of, right, coefficient of x square, right? Coefficient of y square, this will be 1/2 coefficient of xy. This is symmetric, so this will be 1/2 coefficient of xy. ঠিক, so the associated matrix will be, here the coefficient of x1 square, that is 5, coefficient of y, just you consider x1 is x, x2 is y, x1 কে তুমি x consider করো, x2 কে তুমি y consider করো, 5 minus 1, x1 x2 coefficient 2, মানে x1 x2 means xy, ঠিক আছে? So x1 x2 coefficient 2, so to the divide, so this will be 1, so this will, so this is the associated matrix. This is the associated matrix for this real quadratic form. Okay, ঠিক আছে? So next example, so this is very important. For 2 cross 2 matrix we get a real symmetric matrix. Okay, so next if we consider this example, suppose we have a real quadratic form x1 x2, right, minus x2 x3. So what is the associated matrix? See this coefficient of x square, diagonal গুলো কি হবে? Principal diagonal, coefficient of x square, coefficient of y square, coefficient of z square, ঠিক? So x1 কে তুমি x কনসিডার করো, x2 কে তুমি y কনসিডার করো, আর x3 কে তুমি z কনসিডার করো, ঠিক আছে? So what is the matrix? So coefficient of x square absent, মানে x1 square present নেই, that is 0. Coefficient of y square, y is x2 square is absent, that is 0. Coefficient of z square, that is 0. 1/2 coefficient of xy, that is 1/2 coefficient of x1 x2, x1 x2 coefficient is 1, so 1/2, that is x1 x2. Coefficient of xz মানে x1 x3 absent, that is 0. Coefficient of 1/2 coefficient of yz means x2 x3, so x2 x3 coefficient minus 1, so to the divide, that is minus 1/2. This is symmetric, so this is 1/2, so this will be 1/2, that is 0, so this is minus 1. So this is the associated matrix for this quadratic form. Getting my point? Okay, so this is the associated matrix. This is the associated matrix. Okay, so similarly if we consider this example, so see this, here we have 3 variables x1 x2 x3, so we get a 3 cross 3 real symmetric matrix. Okay, next if we consider this example, suppose what is the expression here? The expression is x1 square, right, x1 square, okay, minus x2 square plus 2x3 square. We have 3 variables x1 x2 x3, so we get a 3 cross 3 real symmetric matrix. Okay, we get is 3 cross 3 real symmetric matrix. So coefficient of x1 square, that is 1, coefficient of x2 square, that is minus 1, x3 absent, coefficient of x3 square, that is 0. 1/2 coefficient of x1 x2 absent, x1 x3 absent, x2 x3 absent, right? So this is a symmetric matrix, so this is 0, this will be 0, this will be 0, and this will be, so this is the associated matrix for this quadratic form. Okay, that means Q is x transpose x. So what is x here? Here x is x1 x2 and x3, right? So x transpose, so column will be row, that is x1 x2 x3, this matrix, that is 1 0 0 0 minus 1 0 0 0 0, right? X is x1 x2 x3. So if we multiply this, you get this form. So every quadratic form can be represented in matrix form, x transpose x, this form, right? Okay, please correction this will be 2, right? This will be 2. Here the coefficient of x3 square, that is 2, so this will be 2. Please correction this. Okay, so now I will discuss what is positive definite, what is positive semi-definite, what is negative definite, what is negative semi-definite, and what is indefinite. That is very important. That is very important. That is very important. What is positive definite? A real quadratic form, suppose Q, a real quadratic form, that is X transpose AX. This is positive definite if Q is greater than 0 for all X. If Q is greater than 0 for all X not equal to 0. So that means it is positive definite. It is positive definite if Q is strictly greater than 0. Okay. For all X not equal. What is X? X is means suppose the quadratic form is 3 variable x1 x2 x3, that is x is x1 x2 x3. ঠিক আছে? Okay. So positive definite for condition টা কি Q must be greater than 0 for all x not equal to 0. For all x not equal to 0. Positive semi definite. Positive semi definite. Positive semi definite if Q is greater than or equal to 0. Okay. Q is greater than or equal to 0 for all x, and there exists some x for which Q is equal to 0. For some x not equal to 0. Okay, that is very important. Positive semi-definite will be Q is greater than equal to 0. That means Q is greater than 0 for all x, and Q is 0 for some non-zero, for some x not equal to 0. Okay? We consider an example to clear this concept. Don't worry. And what is negative definite? Negative definite if Q is less than 0 for all x not equal to 0. মানে Q টি কি হবে? Less than, that is Q is negative. Okay. Negative semi-definite if Q is less than equal to 0 for all x and Q is equal to 0 for some x not equal to 0. And indefinite, that means greater than equal to 0 for some x not equal to 0 and less than equal to 0 for some other x not equal to 0. We consider an example to clear this concept. Let us consider an example. So positive definite কখন হবে? If Q is greater than 0 for all x not equal to 0. Positive semi-definite Q is greater than equal to 0 for all x, but there exists some x for which there exists some non-zero x for which Q is 0. Okay. Negative definite, that is Q is less than 0, that is Q is negative for all x. For all x. So negative semi-definite if Q is less than equal to 0 for all x and Q is equal to 0 for some x not equal to 0. Okay. And indefinite means if Q is greater than equal to 0 for some x not equal to 0 and Q is less than equal to 0 for some other x not equal to 0. So let us consider an example to clear this concept. Suppose, note this problem. Suppose we have, let us consider an example. Suppose we consider this quadratic form. Note this, x1 square, okay, plus 2x2 square plus 4x3 square, right, plus 2x1 x2 minus 4x2 x3 minus 2x3 x1. Note this. Suppose we have a quadratic form x1 square plus 2x2 square plus 4x3 square plus 2x1 x2 minus 4x2 x3 minus 2x3 x1. See this. This can be written as x1 square plus, this can be written as x1 plus x2 minus x3 whole square, right, plus x2 minus x3 square. Okay. So minus x3 square minus x3 square. So here x3 is absent, right? 4x3 square. So this will be plus balance, that is 2x3 square. See this. This expression can be written in the form, দেখো, a plus b minus c, that is a square plus b square plus c square, that is x1 square plus x2 square plus x3 square, x3 square plus x3 square, that is 2x3 square plus 2x3, that is 4x3 square. Okay, 2x1 x2, 2x1 x2, right? x1 x2 minus x1 x3, right? Minus x1 x3 minus 2x1 x3, right? Minus 2x2 x3, and here minus 2x2, that is minus 4x2 x3. ঠিক আছে? So square, দেখো, square, so that must be always positive, right? So here this expression, that is this is greater than or equal to 0 for all x is x1 x2 x3 series. কেন গ্রেটার দেন ইকুয়াল টু 0 কখন হবে? দেখো আমি এমন একটা ভ্যালু চুজ করি, if we consider সাপোজ কিউ কখন 0 হবে, যদি তুমি x1 0 চুজ করো, if x1 is 0, x2 is 0 and x3 is 0. If x1 is 0, x2 is 0 and x3 is 0, then q is 0. Otherwise it is non-zero. Yes or no? That means q is 0 only when this is 0. That is x1 is 0, x2 is 0, x3 is 0, তখন এটা 0 হবে. Otherwise this is positive. Getting my point? Otherwise it is positive. This is strictly greater than 0 and this will be 0. This will be 0 if x1 0, x2 0, x3 0. See this. This is always positive, right? So this is always greater than 0 and this expression will be 0 if x1 x2 x3 is 0. কোন কন্ডিশন কে স্যাটিসফাইড করছে? q is greater than 0, q is greater than 0 and for all x not equal to 0. দেখো যদি x এর ভ্যালু গুলো, আমি x মানে কি, what does it mean? X means here x1 x2 x3. মাত্র এই এক্সপ্রেশনটা কখন 0 হতে পারে? যদি x1 0, x2 0, x3 0 হয় তাহলে এটা 0 হবে। আদারওয়াইজ যে কোনো নন জিরো ভ্যালুর জন্য দ্যাট মাস্ট বি অলওয়েজ পজিটিভ। ঠিক? ওকে, সো দিস ইজ পজিটিভ ফর অল এক্স and this expression is 0 only if x1 is 0, x2 is 0, x3. So this condition is satisfied. Okay, that is q is greater than 0 for all x. Q is greater than 0 for all x. X means here, x means x1, x2, x3. ঠিক? And this is 0 when এটা 0 কখন হবে? যদি x1 একমাত্র পজিটিভ, যদি 0 কখন হতে পারে? যদি x1 0, x2 0, x3 0 হয় তাহলে এটা 0 হবে। বাট কন্ডিশনটা কি বলছি? ফর অল x নট ইকুয়াল টু 0, মানে আমি নন জিরো নাম্বারের জন্য যদি এটা 0 হয়, দেখো এই কন্ডিশনে কি বলছে, x নট ইকুয়াল টু, দ্যাট মিন্স আমি আমার নন জিরো নাম্বার চুজ করব যার জন্য যদি কিউটা 0 হয় তাহলে সেটা পজিটিভ সেমি ডেফিনিট হবে। কিন্তু যদি এমন কোনো নন জিরো নাম্বার এক্সিস্টই করছে না, একমাত্র দেখো জিরোর জন্য তো অবশ্যই 0 পাচ্ছি, রাইট? যদি x1 0, x2 0, x3 0 হয় তাহলে অবশ্যই 0 হয়ে যাচ্ছে। So this is greater than 0 for all x and this is 0 only if x1 0, x2 0, x3 0. So this must be a positive definite. That means the quadratic form q is positive definite. বোঝা গেল? ক্লিয়ার? ঠিক আছে। What is positive definite? q is greater than 0 for all x. Q is greater than 0 for all x not equal to 0. So here we see that q is greater than 0 for all x not equal to 0. ঠিক? তাহলে 0 কখন হবে? যদি একমাত্র পসিবিলিটি x1 x2 x3 0 হয় তাহলে এটা 0 হবে। So this is positive definite. ওকে, আর পজিটিভ সেমি ডেফিনিটের কনসেপ্টটা কি? পজিটিভ সেমি ডেফিনিট কনসেপ্টটা হচ্ছে এরকম, যে কিউ ইজ গ্রেটার দেন 0, কিউ ইজ গ্রেটার দেন 0 ফর অল এক্স, বাট দেয়ার এক্সিস্ট সাম non-zero x, there exists some non-zero x for which q is 0. Getting my point? Positive semi-definite means q is positive for all x, but there exists some non-zero number for which q is 0. Let us consider an example. Suppose if we consider this expression, okay, suppose we consider this quadratic form. Q is equal to x1 square plus 2x2 square plus 2x3 square, okay, plus 2x1 x2 2x1 x2 minus 4x2 x3 minus 2x3 x1. See this expression, see this quadratic form, okay. So this can be written as x1 square, so q can be written as, see this, x1 plus x2 minus x3 square, okay, plus x2 minus x3 square. You can check this, a plus b square plus b square plus c square, so x1 square plus x2 square plus x3 square. From this x2 square plus x3 square, so x3 square plus x3 square, that is 2x3 square, right? So 2x1 x2 present minus 2x1 x2 minus 2x1 x3, right, plus minus 2x2 x3, and from here minus 2x2 x3, that is minus 4x2 x3. So this is balance, okay. Now see this expression very carefully. Here what is q? Basically what is q? Q is a function of x1 x2 x3. So basically this is x, okay, this is a square term, that must be, that is positive always, that is q is greater than 0 for all x, for all non-zero x. Getting my point? This is greater than 0 for all non-zero x. What is positive semi-definite? If there exists some non-zero real number for which q is 0, there exists some non-zero real number for which this expression is 0, then it is positive semi-definite. For example, if we consider x1 is 0, x2 is 1 and x3 is 1, right? That means this pair x1 is 0, x2 is 1 and x3 is 1. So obviously this is x, this is not equal to 0, this is 0 if all terms are 0. Now just you put this x1 এর value 0 put করো, x2 is 1 and x3 is 1 put, that is this expression is 0. দেখো x1 0, x2 1 আর x3 1 put করো, that becomes 0. That means, so what we get? q 0 1 1 for which q is 0. বোঝা গেল? আলটিমেটলি কি পাচ্ছি? What we get? That is q is greater than 0 for some x, so for all x not equal to 0, but q is 0 for some, for x not equal, for what is x here? X is 0 1 1. For this we get q is 0. দেখো আমি যদি x এর ভ্যালু, x1 এর ভ্যালু, x1 হচ্ছে 0, x is basically here, x is x1 x2 x3, that is 0 1 1. x এর এই ভ্যালুর জন্য আমি কি পাচ্ছি? q 0 পাচ্ছি, ঠিক? So this is positive semi-definite. Getting my point? This is positive semi-definite. This is positive semi-definite. So what is positive definite? If q is greater than 0 for all x, মানে এমন কোনো নন জিরো নাম্বার পাবো না যার জন্য q 0 হবে, ঠিক? যদি এমন কোনো নন জিরো নাম্বার পেয়ে যাই যার জন্য q 0 পেয়ে যাচ্ছি, তাহলে পজিটিভ সেমি ডেফিনিট হবে। ইজ ইট ক্লিয়ার? what is difference between positive definite and positive semi definite? Positive definite is q is greater than 0 for all x, ঠিক? q কখন 0 হবে? দেখো এটা 0 তখনই হতে পারে যদি x1 0 x2 0 x3 0 হয়, তাহলেই 0 হবে। সো দিস ইজ পজিটিভ ডেফিনিট। কিন্তু তার মানে এখানে x1 x2 x3 কি সবগুলো 0, কিন্তু পজিটিভ সেমি ডেফিনিট কি হচ্ছে, আমরা এক্স এর এমন একটা নন জিরো নাম্বারের জন্য যদি কিউটা 0 হয় তাহলে সেটা হবে পজিটিভ। কিউ ইজ পজিটিভ অ্যাজ ওয়েল অ্যাজ দেয়ার এক্সিস্ট সাম নন জিরো এক্স ফর হুইচ কিউ ইজ 0, সো দ্যাট ইজ পজিটিভ সেমি ডেফিনিট। অ্যান্ড পজিটিভ ডেফিনিট, there does not exist any non-zero number for which q is 0, মানে এমন কোনো নাম্বার পাবো না যার জন্য কিউটা 0 হবে। দেখো একমাত্র 0 কখন হতে পারে, যদি সবগুলো 0 হয় তাহলে 0 হতে পারে, ঠিক আছে? ওভারঅল কনসেপ্ট এটা দাঁড়ালো যে পজিটিভ ডেফিনিট মানে হচ্ছে সমস্ত এক্স এর সমস্ত মানের জন্য পজিটিভ হতে হবে, ঠিক? আর পজিটিভ সেমি ডেফিনিট মানে হচ্ছে এক্স এর সমস্ত মানের জন্য পজিটিভ, কিন্তু এক্স এর এমন একটা মান যদি পেয়ে যায়, এমন একটা ভ্যালু পেয়ে যায় যার জন্য কিউটা 0 হবে, দ্যাট ইজ পজিটিভ সেমি ডেফিনিট, ঠিক আছে? ওকে, ক্লিয়ার? সো লেট আস কনসিডার অ্যানাদার এক্সাম্পল। হোয়াট ইজ ইনডেফিনিট? What is indefinite? Suppose if we consider this quadratic form, x1 square plus x2 square plus 2x1 x2 plus 2x2 x3 plus 2x3 x1, so a square plus b square, so this can be a square plus b square, suppose plus x3 square, right? So minus x3 square, so x1 plus x2 plus x3 whole square minus x3 square. We can write this, right? Okay, দেখো আমি যদি what is q basically? Q is x1 x2 x3. Now suppose we choose x1 is 1, okay, x1 is 1, x2 is 1 and x3 is 0. That means q1 1 0. What do we get? Now this, what do we get from this? 1 1 0, that is 2a square, that means ultimately 4, that is positive. Q is positive for some, so q is positive for some x1 x2 x3, okay? And again if we consider the value, suppose x1 is 0, okay, x2 is minus 1 and x3 is 1, okay, so that means in that case q 0 minus 1 1, so what, x1 x2 plus x3, that is 0, so minus 1, right? So that is negative. So for some x1 x2 x3, so for some x1 x2 x3 q is positive, and for some values of x is q is negative. So this is positive, positive as well as negative, so that is indefinite. Getting my point? Is it clear? So there exists some value of x, so this is basically x, this is basically x, this is basically, so there exists some non-zero x, obviously this is not equal to 0, right? This is x is not equal to 0, this is not equal to 0. So for some x not equal to 0, we get q is positive, as well as for some x not equal to 0, we get q is negative. So positive as well as negative, so this is indefinite. So this real quadratic form is indefinite. Okay, clear? So positive definite means this must be greater than 0 for all x not equal to 0. Okay, ठीक? Positive semi definite, that means q is greater than 0, but there exists some x, value of x for which q is 0, then it is said to be positive semi-definite. Similarly, if q is negative, then similarly if q is less than 0 for all x not equal to 0, then it is negative definite. If there exists some x, that is there is some non-zero x for which q is 0 as well as q is negative, then it is negative semi-definite. Okay, clear? See this, it is a very important result. It is a very important result. It is a very important result. That is a real quadratic form. It is positive definite if all eigenvalues are positive. If all eigenvalues are positive, then it is positive definite. If all eigenvalues are negative, if all eigenvalues of a matrix, that is of a matrix, that is associated matrix, is negative, then it is said to be negative definite. If there exists one, suppose one eigenvalue is positive, suppose if we get this type, suppose 2 3 0, this is positive and we get 1 0 eigenvalue, so that is positive semi-definite. Take, that is positive semi-definite means if an eigenvalues of a is greater than equal to 0 and there exists one eigenvalue that is 0, then it is said to be positive semi-definite. Okay, next, what is a negative semi-definite? Negative semi-definite, that means eigenvalues are negative and there exists one 0 eigenvalue. Okay, take, and indefinite, that is positive eigenvalue as well as negative eigenvalue. Okay, so positive definite means all eigenvalues are positive. For example, if we have a 3 cross 3 matrix, suppose we get the eigenvalues 2 3 4, all eigenvalues are positive, so this is positive definite. Negative definite কখন হবে? If all the eigenvalues are negative, all eigenvalues, suppose 2 minus 3 minus 1, all eigenvalues are negative, so that is negative definite. Positive semi-definite, that means eigenvalues are positive, suppose 2 3 and one eigenvalue is 0, then it is positive semi-definite. Okay, negative semi-definite, that means eigenvalues are negative, suppose minus 1 minus 2 and there exists one 0 eigenvalue, that is negative definite. And what is positive, what is indefinite? There exists positive eigenvalue as well as negative eigenvalue. Okay, ঠিক? So eigenvalue concept দিয়ে আমরা positive definite, positive semi-definite, negative definite, negative semi-definite, indefinite conclusion করতে পারি. Okay, so it is very important, it is very important. We use this result also. We use this result. A real quadratic form x transpose x, okay, in n variables. Suppose x, that is a real, suppose a real quadratic form in n variables x1 x2 up to xn, then it is positive definite. Then it is positive definite if and only if a1, what is a1? That means this position a11, if a11 is greater than 0. a2, that means suppose if we consider a 3 cross 3 matrix, obviously for a real quadratic form the matrix must be real symmetric matrix. So if we consider a matrix like this, suppose a11, okay, a12, a13, suppose a21, this matrix must be symmetric. Okay, a12, a21, a23, okay, a31, that means a13, a23 and a33. This is a symmetric matrix. Okay, right? So first we calculate, just see a1, that is this position, that is a1, that must be positive. a2, that is, we consider this, okay, that is second order principal minor, that means a2 means here a11, okay, a12, a22, a22, ठीक, that means determinant of this. Okay, and A3 that is determinant of this. Okay, that is determinant of this matrix. If all are positive, then it is said to be positive definite. Getting my point? A real quadratic form Q in n variables is said to be positive definite if A1, that is this position, is greater than 0, A11 is greater than 0. Okay, A2, that means determinant of this, that is A11, A12, suppose A21, A22, this position is determinant of this matrix is 0, and A3, that means determinant of this is positive, then it is said to be positive definite. Okay, right? So let us consider an example. Suppose, see this matrix. Here the given matrix is, what is the matrix here? Here the matrix is, see this is the symmetric matrix, right? 3, -1, 0, right? -1, 2, -1, 0, -1, 3. Okay. So this position is A11, right? This is A11. So what is A11? That means A11, that means this position, that is 3. That is this, simply just we denote this A1. Okay. Next, A2, that means determinant of this, that is 3, -1, 3, -1, -1, 2. And what is A3? A3 is determinant of this matrix, that is 3, -1, 0, -1, 2, -1, 0, -1, 3. So this is positive, right? If we calculate this, 6 -1, that means 5, that is positive. And obviously you can calculate this. If you calculate this, that is 3 into 6 -1 -1 into -3, right? Okay, -1 into +3, that means -3. So ultimately that means that is positive, right? So A1, that is positive, A2, that is positive, A3, that is positive. So this is a positive definite, that is the quadratic form must be positive definite. Clear? Okay, ठीक? So it is very important, that is very important result. If all the principal minors of a matrix are positive, then the matrix is positive definite. The matrix is positive, that means the real quadratic form must be positive definite. So it is a very important result. If all the principal minors of a matrix, that means suppose this A11, A2, that is this matrix, A3, that is determinant of this. So if the all principal minors are positive, if all the principal minors of a matrix are positive, then that must be positive definite. Okay, ठीक? Okay, so let us consider next example. See this problem. Which of the following matrices are positive definite? Which of the following matrices are positive definite? See this. দেখো এই টার্মটা পজিটিভ, রাইট? So আমি minor method দিয়ে solve করি. If we solve this problem by binary method, so here A1 is 2, that is greater than 0. What is A2? A2 is 2, 1, 1, 2. That is 4 - 1, that is 3, which is greater than 0. So this is positive definite, right? For option B, see this. Here A1 is A11 is 1, which is greater than 0. A2, that is determinant of this, 1, 2, 2, 1. 1 - 4, that is -3, which is less than 0, that is negative. Next, this cannot be a positive definite, that is this term is A1, that is negative. Take here, if we calculate this determinant, that is negative, so only possibility is this. Okay, So with the help of minor method we can easily check that this is a positive definite. আমরা এই প্রবলেমটা আইগেন ভ্যালু দিয়ে সলভ করতে পারো, ঠিক আছে। we can solve this problem, we can also solve this problem with the help of this result. That means positive definite if all the eigenvalues are positive, negative definite if all the eigenvalues are negative, and positive semi definite if all eigenvalues are positive and there exists one zero eigenvalue, ठीक। negative semi definite, that is some eigenvalues negative and zero, right? Indefinite, that is positive as well as negative. So we can solve this problem also this ways. This is the 2x2 matrix. So what is the characteristic equation? What is the characteristic equation? What is the characteristic equation for a 2x2 matrix? The characteristic equation is lambda squared minus trace A into lambda plus determinant A, right? So this equal to 0. That means lambda squared minus what is the trace? Trace is the sum of the diagonal elements. That means 4 minus 4 lambda plus determinant. Determinant is 4 minus, that is 3, right? So if we factorize this, that means lambda minus 3 into lambda minus 1 is equal to 0, right? So that means the eigenvalues are 1, 3. Okay. Obviously this is a symmetric matrix, right? Note that for a real quadratic form the matrix must be symmetric matrix. So the eigenvalues are positive. That means this is a positive definite matrix. That is, the real quadratic form must be positive definite. So if we consider next example, suppose for option B, what is the characteristic equation? What is the characteristic equation? The characteristic equation is lambda squared minus trace A into lambda plus determinant A is equal to 0. Okay, that means lambda squared minus trace. What is trace? Trace will be sum of the diagonal elements, that means 2, right? So minus 2 lambda plus determinant. So what is the determinant value? 1 minus 4, that is minus 3. Minus 3 is equal to 0. ठीक? So if we simplify this, so lambda minus 3 into lambda plus 1 is equal to 0, right? Okay, so that means lambda is 1 minus 1 and 3. Minus 1 minus 1 3. ठीक? So one value is positive and another value is negative, so that is indefinite. So this is indefinite, that is the real quadratic form is indefinite. So we can also check with the help of this result. Okay, ঠিক আছে? Okay, so let us consider next example. Okay, for example, see this. The eigenvalues are 3 minus 1, that is indefinite. If we what is the eigenvalues of this? The eigenvalues of this, if we calculate, the eigenvalues are minus 4 minus 1. All eigenvalues are negative, that is negative definite. Okay, 0 4 4 0. The eigenvalue, if we calculate this, eigenvalues are 4 minus 4. Positive as well as negative. Positive eigenvalues as well as negative eigenvalues, that is indefinite. Clear? Okay, so next problem. Same bhabe you can solve this problem. Only one of the following matrix is non-negative definite. Non-negative definite, what does it mean? Non-negative definite, that means positive definite. Non-negative definite, that means positive definite. Okay, so obviously তুমি minor method দিয়ে solve করতে পারো or eigenvalues find out করে তুমি solve করতে পারো, ঠিক আছে? Okay, so first if we check this, so we have to find the matrix which is positive definite. So here A11, that is A1, that is A11, that means 5, which is greater than 0. A2, that is determinant of this 5 minus 3 minus 3 5, that is 25 minus 9. that is 16, which is greater than this. So that is positive definite. Okay, ठीक, clear? So this will be, this cannot be positive definite. এটা positive হতে পারবে না. This is not positive definite. Okay, so option A is the correct answer. Next problem. See this problem. The quadratic form x1 square plus 5x2 square plus 2x3 square. The quadratic form x1 square, right, plus 5x2 square plus 2x3 square minus 4x1 x2 minus 6x2 x3 plus 2x3 x1. Okay, clear? So what is the associated matrix? What is the associated matrix? The associated matrix is the coefficient of x1 square, that is 1, coefficient of x2 square, that is 5, coefficient of x3 square, that is 2, 1 by 2 coefficient of x1 x2, that is minus 2, x1 x2 x1 x3, that is x1 is the coefficient 2, that is divided by 2, that is 1, x2 x3 coefficient minus 3, that is minus 6, so divided by 2, that is minus 3, right? So this is symmetric, so minus 2 1 minus 3. So if we find the eigenvalues, if we calculate these eigenvalues, the eigenvalues are 0, 4 plus minus root 3. So just see this, 0, 4 plus root 13, and another eigenvalue is 4 minus root 13. 4 minus root 13. Okay, so this is positive, this is positive, right? One eigenvalue is 0, so that must be positive semi definite. Clear? If we calculate these eigenvalues, the eigenvalues are 0, 4 plus minus root 3, 0, 4 plus minus, that means one eigenvalue is 4 plus root 3 and another eigenvalue 4 minus root 3, so 0, that is positive semi definite. One eigenvalue is positive and another, one eigenvalue is 0 and another positive, so this is positive semi definite. Okay, so next problem. See this problem. I think same problem, you can solve this problem, same type problem. Just see this example. See this example. The quadratic form y1 square, right, plus 2y2 square plus 2y3 square plus 2y1 y2 minus 4y2 y3 minus 2y3 y1. খুব ভালো করে বোঝার চেষ্টা করবে। এটাকে যদি আমি কোয়াড্রেটিক ফর্মে আমি যদি 3x3 ম্যাট্রিক্স, that is associate, what is the associated matrix? What is the associated matrix? The associated matrix is the coefficient of y1 square, that is 1, coefficient of y2 square, coefficient of y2 square, that is 2, coefficient of y3 square, that is 2, 1 by 2 coefficient of y1 y2, right, xy, 1 by 2 coefficient of xy, xz yz, xy xz yz, right? So y1 y2 এর coefficient 2, that is divided by 2, that means 1, y1 y2, y1 y3, y1 y3 coefficient minus 2, that divided by 2, that is minus 1, coefficient of y2 y3, 1 by 2 coefficient of y2 y3, that is minus 2. Can you remember this result? Can you remember this formula? That is 1 by 2, just see this form, coefficient of x square, that is coefficient of y1 square, coefficient of y2 square, coefficient of y3 square, 1 by 2 coefficient of y1 y2, x কে তুমি y1 কনসিডার করো, y কে তুমি y2 কনসিডার করো, আর z কে তুমি y3 কনসিডার করো, 1 by 2 coefficient of xy, that is coefficient of y1 y2, 1 by 2 coefficient of y1 y3, 1 by 2 coefficient of y2 y3. ঠিক? Okay, so this is, see this, so this is a symmetric, that is this is 1, দিস ইজ -1 and this is -2. এবার তুমি এর আইগেন ভ্যালু ফাইন্ড আউট করতে পারবে। এর আইগেন ভ্যালু ফাইন্ড আউট করে যদি সমস্ত আইগেন ভ্যালু পজিটিভ হয় তাহলে পজিটিভ ডেফিনিট, যদি সমস্ত আইগেন ভ্যালু নেগেটিভ হয় তাহলে নেগেটিভ ডেফিনিট, যদি পজিটিভ এবং নেগেটিভ আইগেন দুটোই থাকে তাহলে ইনডেফিনিট। ঠিক, যদি আইগেন ভ্যালু দুটো পজিটিভ, মনে করো একটা 0 পাচ্ছ তাহলে পজিটিভ সেমি ডেফিনিট, যদি নেগেটিভ থাকে 1 is 0 that is negative semi definite. If all eigenvalues are negative, if all eigenvalues are negative then that is negative definite. ঠিক, তো অনেকটা লেন্দি হবে। তাহলে এটা দেখো আমরা এই ফর্মে কনভার্ট করতে পারি। see this is q, right? This can be written as y1 square plus 2y2 square plus 2y3 square plus 2y1 y2, right? 2y1 y2 minus 2y1 y3. So this can be written as y1 ঠিক plus y2 plus y2 minus y3 square, right? Okay, plus y2 minus y3 square. So y1 square plus y2 square plus y3 square, from this plus this will be plus y3 square, that is এটা ব্যালেন্স হয়ে গেছে, plus 2y1 y2 plus minus 2y1 y3 minus 2y1 y3, right? Minus 2y2 y3 minus 2y2 y3, that is minus 4y2 y3, right? So minus y3 plus y3 square plus y3 square plus y3 square plus y3 square, that is plus 2y3 square. ঠিক, ক্লিয়ার? ব্যালেন্স হয়ে গেছে। a square plus b square plus c square, y1 square plus y2 square plus y3 square plus y3 square, that is 2y3 square, right? Okay, right, okay. So this, now see this, is it clear? Okay, plus 2y1 y2 plus minus 2y1 y3, right? Minus 2y2 y3 minus 2y2 y3, this is minus 4y2 y3, right? Okay, now this is square, this is square, so that is greater than 0 for all y1 y2 y3 is not equal to 0. মানে y1 y2 y3 এর ভ্যালু যদি 0 না হয়, that must be positive. ঠিক, okay, clear? For x not equal to 0, this is greater than 0, and if there exists some value of x, that is if there exists some value of y for which q is 0, then it is positive semi definite, right? So here we see that q is greater than 0. Now if we choose y1, suppose y1 is equal to 1, y2 is 1 and y3 is, suppose y2 is 1, suppose y1 is 0, okay, y2 is 1, y3 is 1. See this, y1 is equal to 0, y1 is equal to 0, y2 is 1, y3 is 1, that means q 0 1 1, right? This is non-zero, right? So this equal to, that means 0, that means 0, so ultimately 0. That means q is 0 for some y1 y2 y3, that means suppose this is y, for some y not equal to 0, for some y not equal to 0, this is 0. দেখো, for some there exists one non-zero number for which q is 0, right? So this is positive semi definite. Option B is the correct answer. Clear? Okay, or we can also calculate, just you find out the associated matrix, find the eigenvalues. We see that one eigenvalue is positive and there is suppose two eigenvalues is positive and one there is one zero eigenvalue, then it is positive semi-definite. Clear? Okay. So this is the overall concept of real quadratic form. Okay, so the most important result is this. The most important result is this. Okay, that is the real quadratic form is in positive definite if the minors are positive. That is a1, a11 is greater than 0, a2 that is a11, a12, a21, a22 is greater than 0, an is this. That means all the principal minors are positive, all the principal minors are positive, then the matrix is positive definite, and positive definite matrix, the real quadratic form is positive definite. And this is most important result. Okay, we can solve this problem, these types of problem with the help of this result. Okay, so I think all points are clear to all of you, right? Okay, so this is the 𝗪𝗡 mathematics books. This books is here more than 2200 problem solved. Okay, এখানে 2200 প্রবলেমের বেশি প্রবলেম সলভ করে দেওয়া আছে, পিএসসির প্রবলেমগুলো সলভ করে দেওয়া আছে, বুকের লিংক ডিসক্রিপশন বক্সে দেওয়া আছে, ঠিক আছে? ম্যাথ টেকনিকা অ্যাপে অ্যাভেলেবেল আছে, ম্যাথ টেকনিকা অ্যাপে ডাউনলোড করে দিস ই বুক তোমরা এটা পারচেস করে নিতে পারো, ঠিক আছে? চয়েস ইজ ইয়োর্স। এখানে প্রতি চ্যাপ্টার ওয়াইজ ফোল্ডার করে দেওয়া আছে, দেখে নেবে, ঠিক আছে? থিওরি পার্ট তোমরা ডাউনলোড করে নিতে পারবে, কোশ্চেন তোমরা ডাউনলোড করে নিতে পারবে, বাট সলিউশন ক্যান নট বি ডাউনলোডেড। ঠিক, সলিউশনগুলো নিজেকে সলভ করতে হবে, ঠিক আছে? সলিউশন দেওয়া আছে, বাট সলিউশনগুলো ডাউনলোড এবং প্রিন্টেবল হবে না। ঠিক, থিওরি অ্যাজ ওয়েল অ্যাজ এমসিকিউ প্রবলেম, পিএসসি প্রবলেম সলিউশন দেওয়া আছে, থিওরি এবং কোশ্চেন ইউ ক্যান ডাউনলোড দিস। ওকে, অ্যান্ড দিস ইজ দ্য কোর্স ফর থার্ড এসএলএসটি ফর 9, 10, 11, 12 and PSC that is available on Math Technica app. ওকে, ম্যাথ টেকনিকা অ্যাপের লিঙ্ক ডেসক্রিপশনে দেওয়া থাকবে, সেখান থেকে তোমরা ডাউনলোড করে নিতে পারো অ্যাপটা। অ্যান্ড দিস ইজ দ্য কোর্স ফর থার্ড এসএলএসটি ফর 9, 10 and PSC only. Okay, right? So I think all points are clear. So thank you so much. Bye.